Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 10 from the October 2024, which is the last question in this paper, paper 4, the Pure Mathematics P4 paper from Edexcel International A-Level. It's quite a lengthy paper. There's 10 questions in this paper. And here we have the last question about parametric equations. So it says, figure 5 shows a sketch of the curve with parametric equations. X equals 3t squared, y equals sine t times sine 2t, where t is between 0 and pi over 2. The region R shown shaded in figure 5 is bounded by the curve and the x-axis. Show that the area of R is given by this integral k times the integral of 0 to pi over 2 of t times sine squared cosine t with respect to t, where k is a constant to be found. Right, so to save myself from having to keep on scrolling up and down the page, I've got the diagram here and the information that we need here. So they're asking us to integrate find the area under the curve. Right, now to find the area under the curve, if we had Cartesian equations, the area would be the integral of y with respect to x. Okay, the integral of y with respect to x, all right, with the limits x1 and x2. All right. However, we have a third parameter here, t. The equations are given in terms of t, not in terms of a. So what we're going to do here, and we have to show that this is going to give us the area, so we have to use parametrics in this. We can't try to change everything into Cartesian form and then integrate. They want us to use this, show this. So we have to use parametric integration. So it's kind of the same kind of thing as substitution. I'm going to have the limits in terms of t instead of x. I'm going to have y, and y has to be in terms of t. And dx dt also has to be in terms of t. And I integrate that with respect to t. By the chain rule, this looks the same as that. Kind of like something similar to the chain rule. So you have y dx dt dt. If I put everything in this place here, I should come out with this very easily. So the y is already as we want it, but the limits we can see that the 0 and pi over 2, but we should show the limits as well. So we want to find, for example, t1. So we're going to use the x. We know x is equal to 3t squared. Okay. And, all right. So we want to find what t is. In fact, first of all, we have to find these points. This is where x is 0, of course. And we have to find what is this value of x. Okay, now this is where the curve hits the x-axis. At this point, we know that y equals 0. So if I put y equals 0, I have sine t times sine of 2t equals 0. So if I solve this, either sine t is 0 or sine of 2t is 0. So this means t can be 0 or pi or 2 pi. Right? So we have this value 0. This is out of our range, because our range is between 0 and 2 pi. But if I have sine 2t equals 0, I can increase the range to 2 pi. And we know that 2t equals 0. When sine 2t equals 0, that's when 2t equals 0 and pi and 2 pi. And what I can do is I can now divide by 2, because that's 2t. So t is going to be 0 and pi over 2 and pi. That's outside of our range. So this is the other value here. So one of the values is t equals 0, as we got from these two. The other one is pi over 2, which we can actually tell from the interval they gave us, but it's always best to show it. So we know that t equals pi over 2 at these 2 points. Okay, at the point where y equals 0, that's where it hits the x-axis. So we can say that our limits are going to be pi over 2 and 0. Y is as it is, which is sine of t times sine of 2t, and dx dt, well, x is equal to 3t squared, so dx dt is equal to 6t. So this is times 6t, right? And that's sine t, sine 2t times 6t. And that's basically y. That's the x dt, and then we're going to have dt. Okay, so this is going to give us 6 on the outside, and we'll have between pi over 2 and 0. This is going to be, we have to show it becomes this. Okay, so we have a t times. Now, how do we show it becomes this? Well, we have all single angles here. Here we have a double angle, sine 2t. And we know from our understanding of the addition formula that sine 2t, okay, if you use the addition formula, it will be sine t plus t equals sine t cosine t plus cosine t sine t, which is 2 sine t cosine t. It's one of the formulae that we should memorize. If we don't memorize it, we should know how to use the addition formula to derive it. So I can replace, or I should replace, the sine 2t with 2 sine t cosine t. So I have sine t times 2 sine t cosine t. Now I have everything in terms of single angles. Okay, so now I simply have to do the following. I have 6 times the integral between 0 and pi over 2. Now this is going to be 6 times 2. I'm going to take out the 2 out here, so it's going to be 12 on the outside. Okay, that 2 goes out. I've got t times, and now I'm going to have sine squared t cosine t, which is what I think I have to show. Yeah, that's it. So sine t times sine t is sine squared t and cosine t. And that has to be integrated with respect to t. And there we have shown this integral here will give us the area. That's the area of R. Okay, so in this case, our k was 12. And where we found that. Now for the next part of the question, part B, we have to hence, so remember this is 12 now. We have to hence, using what we just found, which is this, using algebraic integration, find the exact area of R, giving you an answer in the form P times pi plus Q, where P and Q are constants. So now we have to integrate this expression. So we have 12 times the integral between 0 and pi over 2 of t times sine squared t cosine t. We have to integrate that with respect to t. Now this I can see, I can integrate this with the reverse the chain rule. Right? So I have a product of 2 separate functions here. So I can use integration by parts, and I like to use the DI method. So I'm going to use DI. And the thing I'm going to differentiate, of course, is going to be the t. That's differentiating with respect to t. When you differentiate, it becomes 1. And when you differentiate again, it becomes 0. So this is one of these easy types that gets to 0. Now the integral of sine squared t cosine t, well, we can think of this as cosine t times sine t all squared. And we can reverse the chain rule for this because we have something of this form where you have a function inside a function, and outside it you're multiplying by some constant times the differential of the function inside. So we can reverse the chain rule. So to do this, what I'm going to do is I'm going to basically, I'll show the steps over here and write the answer there. Basically I'm going to take cosine t times sine t cubed. So I raise the power by 1, divide by the new power, and then multiply or divide by the differential of what's inside the power, which is cosine t. They cancel out, and you're left with 1/3 sine cubed t. Okay, now I have to integrate this. Now, how do I integrate this? And I recall a student saying that, oh, they wouldn't ask us to do something like this. And I have something like this in my notes. Okay, so I don't know how many of the students paid attention to that when they did this exam, or if they did this October exam. Anyway, what we can do here is the following. This is how we can integrate sine cubed t with respect to t. We can rewrite it as sine t times sine squared t. I'm going to show the steps down here and put the answer up in here so it doesn't become a big mess in there. All right. Now this is going to give me a third times sine t, and sine squared t is 1 minus cosine squared t from our basic identities. So this is going to be a third times, if I expand the bracket, I have sine t, and I have minus sine t cosine squared t. And then I have the same situation like this, but the other way around. This time cosine t is inside the function, and outside is a differential of what's inside the function. So I have a third times, now I can integrate it. No integral sign, so a third times, and now it's going to be sine t. When I integrate sine t, I get negative cosine t. And when I integrate this, this is like cosine t all cubed, so I have basically minus, I'll just put this in a separate bracket for now, sine t times cosine cubed t divided by 3, the new power, and the differential of sine t, which is cosine t. Sorry, what am I doing? The differential of what's inside the function. So divided by 3 times the differential of what's inside the function. The differential of cosine t is minus sine t. Okay, so this cancels with this. Minus and minus becomes plus. Okay, so I'm left with this, which is basically 1 over 9 cosine cubed t minus 1 over 3 cosine t. So that's what this becomes here. So it's 1 over 9 cosine cubed t. This is a bit of a hassle here, but minus 1 over 3 cosine t. Okay, now we can now integrate using the DI method. So I'm gonna, this is plus, minus, plus, this times this, minus that times that. Okay, so you have 12 times. Now we have t times, so it's a third, t sine cubed t. Okay, minus, and that's, now be careful here because it's minus all of this. So it's 1 over 9 cosine cubed t minus 1/3 cosine t, and yep, okay, let's make sure something that's good, that's fine. All right, and then I have my limits from pi over 2 to 0. Okay, so you have 12 times a third times t times sine cubed t minus 1 over 9 cosine cubed t plus 1 over 3 cosine t, and the limits between pi over 2 and 0. So now we can put the values in. We have 12 times, okay, a third times, we got pi over 2 times the sine of pi over 2, and I'll write this like this, cubed, because that's what this means, minus 1 over 9 times cosine of pi over 2 cubed plus 1 over 3 times cosine of pi over 2. Okay, now I need to make some space. So let me just take this and move it down a bit. Okay, so we made some space now. So I've got this. Now I've got to put 0 in all of this. That's going to be minus. Now if I put a 0 in here, it's going to become 0. Why? Because you're going to have a 0 there. That'll be 0. That also gives you 0. So I'll just put 0 for now. But be careful. This is not going to become 0. This is 1 over 9 times the cosine of 0 cubed plus 1 over 3 times the cosine of 0. Now we know the cosine of 0 is 1. Okay, the cosine curve 0, it starts from there. Okay, and we know at 90 degrees, pi over 2, it's 0, right? So that's why these are going to become 0 now. So you've got 12, and you're going to have here a third times pi over 2, which is pi over 6. The sine of pi over 2 is 1, so this is going to be 1 cubed. This is going to be 0, this is going to be 0, right? Because cosine of pi over 2 is 0. Okay, and you're going to have this minus, and this is going to become cosine of 0 is 1. You're going to have minus 1 over 9, and that's going to be also 1, so plus a third. Okay, so this is going to be like, if you make this over 9, that's going to be 3 over 9 minus 1 over 9, that's going to be 2 over 9. So you have 12 times pi over 6 and minus, that's going to be 2 over 9. Right, because this is going to be 3 over 9 minus 1 over 9. That's going to be, yes, and that minus will make it minus as well. So we have this. So you have 12 times pi over 6, which is 2 pi, and minus 24 over 9. That's in the form that they wanted. P pi plus q. So this is the form p pi plus q. So we can say p is 2 pi and q is negative 24 over 9. And that is the area, square units of the region required. Okay, R. All right, so that answers this question. So it's a bit complicated, this one, especially the integral, which I moved on to the other page of sine cube t. That's something you should keep in mind from now, right? So something important, okay? Because that's something which really didn't really come before. I have it in my notes. Okay, so those students who went through the notes probably, and they did the exam in October, hopefully they benefited from that. But that's something that's important for us to know right at the end of this question. This is a pretty long question, okay, but we finished the paper finally. So that's it, the end of this paper. I hope you understood, and I hope you benefited and enjoyed going through the paper. Anyway, so if you would like to see other questions from the paper, from this particular paper, the playlist link will appear at the top right of the screen, and at the bottom right of the screen will appear parametric equation, parametric integration, okay, playlist for that. You can also subscribe to my channel by clicking on this link, and the video here will tell you how to use my channel to find what you're looking for. Thank you for watching, and see you soon.